Hello everybody and welcome to this session. So the session code for this is 4BG. So if you can make a note of that ready to fill out your feedback forms at the end. And we'll share that again at the end as well if you're still here by the end. So for this session, we've got Sriram and Deekshit joining us from HSBC. And they're joining us from India today to talk to us about getting started with modern automation for Sysprog tasks. And they're telling us about their user journey. So this session's been recorded and will be available after the conference. And if you've got any questions, please do ask them in the chat window and I can ask them to them either as we go along or at the end. And with that, it's over to you.
Hey, thanks a lot, Sophie, and thanks everyone for joining today. And as Sophie said, this is Sriram Matrabodham, and my colleague Deekshit is going to co-present with us with an opportunity where we can actually share our user journey with the automation of the tasks, which we tried doing it in our shop. And what exactly we are trying to do with this, right? So first thing is we just tried doing, as an objective, we just tried doing a transformation where we tried an infrastructure automation, that is a software automation where the deployment is going to be much easier than what it was before. And the second theme which we tried using is an infrastructure self-service, where the CICS RDO definitions were tried doing online using an automated solution, which my colleague Deekshit is going to take you over. So the first thing is, right, the infrastructure software deployment automation. We just tried taking a non-SMP product and an SMP product where the deployment maintenance, we just tried doing it with the help of a CI/CD, which is the continuous integration and continuous delivery processing, where we just aimed at reducing the manual effort as much as possible, and which is going to help us increasing the service quality and without compromising anywhere in terms of the software quality is concerned. So that's the theme which we tried doing. And the approach which we took is, first, we just gathered as a group of people, and we just tried breaking down the process each and every time so that there is less movement space as possible, or in other words, the number of levers is going to be reduced as much as possible so that it's going to be easy to consume. And how we did that, it's using the DevOps techniques and the tools which actually comes with us, which helps us to automate it and also test it automatically so that our known errors are actually minimized as much as possible. In other words, we can say that it's the modernized way of deployment which we tried doing, right? So that's something which we tried. And you can ask, okay, what is the benefits that we got? Obviously, we just tried seeing if we can actually bridge the skill gap in between the new and the senior Sysprogs, which is actually present in our organization, in any organization, right? And also the second thing, by doing that, obviously, when we're just trying to identify the software defects earlier in the cycle, it's going to be much cheaper to fix it rather than just getting it to the last system in the production. So that's the way which we tried doing. And let's look at an effort as to where did we really start, right? We just tried starting with a product. The first thing is we just had in mind, like, we just need to take a product, which is definitely a non-SMP managed product, because this is something which is a little difficult to manage compared to the SMP way of working. So that's something, a non-SMP product, which means there is going to be a full replacement and there needs to be a checking which has to be done, which library has been changed and what code has been changed has to be checked. If at all people are not tech savvy, they just need to go ahead and rely on the code, right? So that's the thing which we tried taking first. And second thing is we just took a product which does not require any IPL to just go ahead and install, which means that it's not going to make any SDC changes or anything of that sort. And third is we just wanted to take a product which is not so small, just like okay, 1 or 2 people are using, but then the one which has a large customer base or a user base where we can actually go ahead and deploy it across the board. So that's something which we tried. And by doing that, we just picked our journey on the IBM SCRT, which is a subcapacity reporting tool. And this happened to be a non-SMP product. So that's the point of or to say a kind of an eureka moment for us to just go ahead and pick that. So that's the one which we took it. And what we did. So during the installation process, when we just break it down, obviously any product which we go ahead and take it, right? So it will have a tar file which has to be worked with the ZFS or the USS way of working. And so for that, every time when we just receive the maintenance from the vendor, in this case IBM, we just allocate a fresh ZFS every time and then upload the tar files. And once we upload it, we just need to go ahead and extract it and then test the new code and then release it to the environment. This is a full cycle which we tried envisaging so that at any given point of time, it's much easier to manage with the information or the code which we have it, right? So that's something which we tried doing. And obviously for prototyping or automating the whole process, the tools that we used is the first one is zOSMF or zOSMF, which is the IBM's, that is the open mainframe project. So we just have the REST API interface, which comes handy for us. And we use Jenkins as a tool, which is going to help us in the part of the orchestration is concerned. And obviously for the development, which is the IDE, we used the Visual Studio integrated development environment where the coding actually happens. And when we say the coding, obviously it has to be managed in a central place. That's where GitHub came handy for us to make sure that at any given point of time when Jenkins or anybody is actually calling the tool, calling the code for the deployment automation, it comes as a single source of truth. So that's where the GitHub came handy for us, right? And all these tools, just a disclaimer, these are used for experimental purpose. In case in future we just find something useful, we are going to just go ahead and make sure that it's going to be solving our purpose with less or no manual effort involved. So that's the kind of thing which we are trying to do. And all these are specific to shop, and it can vary from shop to shop, right? And second thing is we just tried why we in zOSMF, obviously it gives a lot of APIs where we can actually go ahead and use it. And that's APIs are usually present in the URIs, which is the uniform resource identifiers, where we can actually pick the syntax without much of an effort. And after picking the syntax, obviously we can use the Jenkins pipeline where we can actually generate a pipeline script. It's going to give us how do we handle the ZFS with this, what is that? Excuse me, with the host name being provided, and we can actually allocate or deallocate, or using a tar file, we can actually extract all those things which we can actually use it with the help of a pipeline script builder. And that script is actually taken and we just, as shown in the screenshot, we can actually go ahead and work with the ZFS files with much of an effort. So that's where Visual Studio Code came handy for us. And once we are done, as I mentioned before, the GitHub is going to be very helpful for us so that when the code is being called anytime, it's going to be the single source of truth. So that's where it came handy. By doing all of these, we tried making sure that SART is going to help us where the software deployment for a non-SMP product, it's going to be much faster, and there is going to be as less human error as possible. By doing all these things as an automated process, the end-to-end process, if you look at the whole process, right? So it took us less than 40 seconds. So that's where we tried arriving. And as I said, we are not going to stop here. We are just going to see what are the opportunities where we can actually make sure and improve as we go on, right? So let me take a pause before we just move forward. Are there any questions or concerns? And
There's nothing in the chat so far.
all right. So thank you. So I'm just going to make a move forward for the next, where we went next, right? So in parallelly, we tried starting to test with an SMP installable product where we just try to work on with the SMP products, which is maintained by SMP products. The popular choice was DB2, and the CICS one is for the database and the other one is for the onlines. And the second thing where my colleague is going to take over for the infrastructure self-service for the mainframe, where the team is working on the CSS RDO. So let's take a look at what we tried doing with the SMP products. So for doing that, the tools that DevOps tooling that we used was the prototype was zOSMF and the Jenkins. Obviously, the zOSMF is for the REST APIs and Jenkins for the orchestration. And while calling in the middle, we use the JCL templates just to make sure we do as less coding as possible for the SMP products, right? And let's take a step back and look at what are the steps which is usually available, or in other words, which is usually followed in most of the shops for the packaging, right? So at any given point of time, we just need to go ahead and receive the maintenance from the vendor, which is more likely to be an internet service retrieval. And by doing that, obviously, we just need to run an RSS mode report where it's going to tell us um, what are the places where my system is vulnerable to, and what are the fixes which I need to be worried about, and what are the fixes which I need to definitely take it in so that I'm not going to be exposed to any of the known scenarios, right? And by doing that, obviously with the selected fixes, I can just go ahead and do an apply check so that it's going to tell me what are the required actions that I have to take in case I want to make some software changes at any given point of time. And by doing, once I'm happy with the same, and we can just go ahead and do an apply. And after doing an apply, most of the time we run an IVP, which is actually a JCL, which is present in a PDS or any other shared library. But then we tried using a Jenkins where we can actually have an IVP, which can be triggered at any given point of time where it's going to be repeatable use. And the script is going to be changed in the background so that at any given point of time, it's going to adapt with the new testing scenarios, which we can actually look at, right? So that's something which we tried doing on the end-to-end processing. And once we are happy with everything, we just release it to the environment so that it follows the proper migration path as per the shop standards, depending on the shop, right? So that's something which we tried. And well, we take a little bit more process-oriented value what we do and in the path of order and receiving the maintenance, right? So it again, there's a disclaimer: the process followed in the shop may be different, and what we are sharing is more of a generalized approach. So the ZFS has to be mounted during the time of a receipt, and we have an order server where we actually go ahead and put in the information where we have the internet certificate and the key ring, and obviously the CSI where the software is actually present, in this case, DB2 and CICS, right? And once after that, we have a pipeline, or in other words, a set of template where it actually triggers the RSS modes, where the user can actually use the Jenkins screen to just go ahead and look at the output instead of logging into the mainframe. And you can go ahead and question, okay, I can just do the same using a TWS, or in other words, a control M, or any kind of a scheduling tool. And what is the help, or what is the information that is going to be helpful while doing it via a DevOps tooling, right? So obviously, when you just go ahead and look at it, instead of getting into the 3270 screen, obviously in the Jenkins, it provides a good amount of a web user interface where it's going to be much easier to look at. And most of the new next gen people, instead of getting into 3070, they feel it much more comfortable here. And the amount of time taken for managing the libraries and allowing people to edit it or not, it's going to be much cumbersome. So that's the reason we thought, okay, maintaining it in the Jenkins or anything, it's going to be much easier for us. So we just tried prototyping with the same. But again, as I said before, in case we find anything which is going to be helpful, we are going ahead to try that in the coming future, right? So by doing all these things, when we're just receiving the maintenance, if you look at it, instead of the scheduling tool, the whole timing which we took was just less than 15 minutes. So this helped us to go ahead and look at all the RSS mode reporting after receiving the maintenance for any tools that you may use. And that can be actually went ahead and looked by the Sysprogs to make a proper decision, right? And once after that, the next in the process comes as an SMP apply check, where the user has to just go ahead and look at a specific PTFs. So by doing that, obviously they will be knowing that what are the fixes that I'm getting in, and what is the required hold actions that I have to take. And obviously this is going to be a reusable pipeline, and it is an iterative process, because every time there might be some fixes which can be having a prereq or a correc. So that's the reason we just tried using a multi-line string inputs, so that it's going to be much easier to copy and paste it and work on with as and when we look at the report and make some decision. By doing this, obviously we took less than 5 minutes to the whole process during the apply check. And once we do the same, we can use the same pipeline to just go ahead and do an apply as well. So which is going to affect all the target libraries. And once we're done and happy with all the apply and everything, we just went ahead and do a validation using the set of IVPs, the installation verification programs. So at any given point of time when we just went ahead and triggered it, the whole end-to-end approach took us, that is the IVPs took less than 11 minutes. So if you look at it, at any given point of time, any person who wants to just go ahead and deploy the software, or prepare a maintenance package, right? It takes less than an hour, where it used to take at least 1 or 2 days for the manual ordering and then verification, so on and so forth. So that's the kind of efficiency which we tried achieving in terms of the workability is concerned. So without much of time, I'm just going to pass over the control to my colleague Dikshit. And in case you have any questions or anything that you want, please use the chat tool. We'll be more than happy to go ahead and answer it. Over to you, Dikshit.
Yep. Give me a second. Thanks a lot, Sriram. Good day, everyone. My name is Dikshit. Today, I would like to present about one of our infrastructure self-service solution for defining KICS resources or RDO entries. Again, the name differs in other shops differently. Firstly, let's look into what is CICS and KICS resources are. KICS is a transaction server which requires a set of elements or resources for allowing application programs to run in KICS regions. So basically, there are prerequisites for transactions to be executed inside CICS. For example, most of the application transactions to be executed inside CICS, it requires transaction and program entries to be installed in it. And of course, there are many other resources which are required or may not be required for specific applications to be executed in it. And let's look at why and what exactly the self-service is about. It is all about empowering our application teams to provision infrastructure changes in this case, specifically defining the KICS regions with limited intervention from the KICS system programmers. And there are a couple of advantages which we have noticed. One of which is the major one is it reduces the turnaround time of application deployment cycle, and it also bridges a gap, the skill gap. Now let's move on to the next slide. Okay, now let's look into the differences between the current and the self-service approach. So as you can see, the current approach is quite relevant in most of the shops, where users will gather the requirement and raise a change request via any ticketing tool. And once after submitting a request, the request will be passed to a specific approver. Once the ticket has been approved, it will basically hit the KICS system programmer's queue, which will again the KICS system programmer will go ahead, validate the request, and then he will process the request, which will take approximately 3 days. Again, it based on the shop, if they are following any specific change management process or any maintenance window, it differs. So we have identified a couple of cons around it. Firstly, user need to wait for request to be processed by the KICS system programmer, and as the entire process is manual, there are chances of human errors and longer application deployment cycles. Well, let's look into the self-service approach. As you can see, it is a quite straightforward approach, where application team will need to provide their requirement in the front end, which is Jenkins pipeline here. And once the build has been triggered, in this case, it would trigger an approver. Jenkins will send an email notification to the respective approver. And upon getting the approvers, we have Ansible Tower, which will provision the changes to the mainframe KICS regions. So as you can see, a drastic difference in the turnaround time from approximately 3 days to 5 to 10 minutes for completing the entire process, due to which we can expect shorter release cycles. And a couple of benefits around this is it basically allows application teams to define KICS resources. It provides better auditing capabilities, as we are using tools like GitHub, Jira, and a couple of others, which I'll be explaining in the next upcoming slides. And it will also, as I already mentioned, it takes hardly 5 to 10 minutes for provisioning the changes, due to which we have a shorter deployment cycle. Well, let's move on to the next slide. So here we have tools involved in developing the cell service. Firstly, we have Jenkins for orchestration, and it acts as a front end and for integrating new changes and performing pre-validations. And we have VS Code used for all our development, for developing the scripts, automated scripts, Jenkins pipelines, Jenkins files and Ansible playbooks. And we also used GitHub and Git, which plays a major role in this entire cell service, which is Git is integrated with the mainframe USS, which is used as an SEM. And we have Ansible, which is used for configuration management. Again, it acts as an endpoint for provisioning changes on the mainframe. And last but not the least, we have Python and Rex scripts and a couple of other mainframe specific scripts like JCL and all used for automating the backend tasks. And finally, we use Jira for recording all the requests triggered via self-service for auditing purpose. Let's move on to the next slide. So this is the architecture we was designed to develop the Kix resources self-service. For better understanding, I have given a numbering here just to understand the workflow, to represent the workflow and for referring it back whenever someone is interested. So let's get started. So getting started with the user block here, who is a developer whose responsibility is for inputting all the details in the front end, which is Jenkins pipeline, and trigger the build. Next, Jenkins will fetch the existing Kix resources from the GitHub repository, which is in the step 2 here. And what it does is it will do some pre-validations and comparisons, do some sanitary checks, etc. And then it would trigger an email notification in the step 3. That email notification basically contains the requested details and other details which is required by the respective approver for reviewing it and providing the approvers. So once the approvers have been provided, it would what Jenkins will do is it will update the new changes to the GitHub repository, and then it would trigger an Ansible template on the Ansible tower. So this brings us to the beginning of provisioning the changes onto the Kix regions. So here you can see there is a block. So this is a main block which contains a flow of entire workflow, which helps to process which represents the process of provisioning the changes on the Kix regions. So we had a play in the playbook. What it does is it will fetch the changes, new changes from the GitHub to a Git, which is again maintained on the SSH of the respective repository, and it will update the data set, followed by it will trigger a couple of JCLs, and it would give a physical entry inside the CSD file. And finally, it would install all the new requested resources into the Kix regions. That will come somewhere here. So now we came to the end of provisioning the changes on the Kix regions. And we also had a custom dashboard, which is maintained in the backend, which is used for recording the usage statistics, number of requests, who is a requester, and what is a request for, etc. And the dashboard here. So the next, once the provision and the dashboard update has been successfully completed, the control will be written back to Jenkins here, and it will trigger an email notification stating that your request has been successfully completed. You can start kind of deploying your application and perform your testing. And at the end, we have a Jira ticket which will be triggered basically for auditing purpose, where we are recording the required request details and other things based on the cyber security suggestion. So this is the entire architecture which helped us to kind of develop a self-service solution for Kix resources. And last but not the least, finally, the access of the front end, which is Jenkins in this case, is controlled by an access control database. Again, it can be an AD or any other custom access database based on the shop. Okay, now let's move on to the next slide. So And before going to this slide, a quick disclaimer here. As all the tools used in this architecture is completely relevant to the standards of the shop and cyber security, we have multiple tools in the market with a similar kind of functionalities. So it's individual responsibility to identify the standard tools used in their shop and adopt the same in the architecture and get it reviewed by the cyber security. Well, let's move on to the next slide. So this is a front end where developer will input their requirement, and most of the fields are mandatory and a couple of them are optional. So firstly, we had a project details field, which is a mandatory field where user need to input what is a project he's raising the request for. And then we have an action field where the user have an option to select three different actions. One is define, delete, and alter. If you want to delete a resource, define a resource, or alter an existing resource. Next, we have another optional field called dynamic install, which is again an optional field where the user can select whether he want to get the changes reflected immediately or he can go for a restart later based on his maintenance window. Next, we have a resource field. Currently, we have given three options to the user where he can go ahead and define, delete, and alter transactions, programs, or transaction class entries. So going forward in future, we are expecting to give kind of allowing them to make changes to files and all. Again, it's based on the project requirement. Next field is region names, where the user can provide all the Kix regions where he want to make changes for, followed by which he have a resource name field where he need to provide all the new resources or the existing resources you want to define, delete, or alter. So finally, we have attribute field here, which is basically used for providing the custom attributes. If it is ignored, uh, it would automatically pick the default attributes. So once all these fields are filled by the user, he can just click on the build button so that whatever the workflow which I have discussed before will be processed, and it will provision the changes on the Kix regions. And let's move on to the next slide. So here we have a complete view of the workflow which will be taken place after the request has been triggered. So as you can see, there are 5 steps. The first one is a checkout where it will check out the existing code from the Git repository, and it will do the pre-validations by comparing the request provided by the user, and it will do some pre-validations by comparing with the existing code, and then it will trigger an approval request which will send the email notification to the respective approver, and upon his approval the changes will be provisioned on the mainframe, and finally it will trigger some usage statistics and email notifications and a Jira ticket for auditing purpose and identifying the usage statistics purpose, and to also find out who did what and when. So yeah, this is all about what I would like to present about infrastructure self-service solution. Thanks a lot for all your interest and attention. I would like to hand over it back to Sriram for covering remaining slides. Thank you. Over to you, Sriram. I'll stop my share.
Hey, thanks, Dikshit. And for everybody here, just in case if you guys are interested in any questions or anything that you have, please feel free to reach out, raise, or please present in the chat so that we can go ahead and answer. And with respect to whatever we discussed so far with respect to the software automation, deployment automation that we tried doing, and also the infrastructure self-service for the CICS RDO, right? So this is a future direction which we are trying to do. So we're just trying to use each and everything which we develop as a Lego blocks so that we can actually mature as we move forward. And as we said before, it's not where we are going to stop. We just want to make sure that we go ahead and collaborate and make sure we carry the best practices, which is going to help us. And by doing all these things, we just embrace change by reducing the manual effort wherever possible and without compromising the quality of the delivery, right? So that's what we're trying to do. And obviously, this is something like we take it as an opportunity in the user journey where we say that, okay, infrastructure, you people just go ahead and manage things, but what it comes to the development. So that's the challenge which we actually tried taking. And this is how we are so far. And it's a journey which is yet to be completed. So by doing all these things, the benefits that we tried doing is we were able to produce or deploy the software in a much faster, and obviously in terms of the infrastructure self-service is concerned, which gave the flexibility just to go ahead and say that, okay, instead of waiting for a long time, I'm able to get something done in a much faster pace, right? So by doing that, obviously we were able to bridge the skill gap to a little extent. And obviously this is a process where we actually require to have a continuous improvement in place. And obviously how we are going to do this is by adopting the new CI/CD tools, which is going to be there. And it's a tool of choice. Obviously, it depends on the shop standards. And by doing all these things, we're just looking something where the solutions, whichever we develop, it's easy to consume. And it's not just the technology for the customers, it's technology for ourselves. So it's going to be much easier and a fun way to do going forward, right? So that's the kind of thing which we tried doing for ourselves. And that's the one we had. And we are open for any questions in case you may have. Thanks for the opportunity, by the way.
Thank you. So I'm just going to allow people to unmute themselves if they want to ask any questions.
Sure.
Okay, so you should be able to unmute yourself now if anyone has a question. Okay, so I've got one in the chat. So how are the new SMP target delib zones for new maintenance integrated in this process of automation?
Okay. When someone is actually trying to go ahead and, okay, when we're just trying to apply any maintenance, obviously the CSI will have the information of the target and the distribution libraries, right? So it depends on the CSI which you choose. And in case we are moving to a different CSI for every other maintenance, obviously we just need to make changes a little bit in the back end. So in terms of the integration is concerned, we're just trying to try to do it as a part of the coding itself, where it is stored in the GitHub. But in case if you're just trying to do something manually and try to make a code which is as less as possible, you can still do it via JCLs, where you actually use the symbolics and try to integrate. So that's the way we tried doing in both the ways, actually.
Okay, and then you've got another question as well. How much time did you need to put that solution in place?
Obviously, it is more of an iterative process. I hope that's something for which you're asking for the software automation. So that's something which we tried, and it was more like we worked for more than 4 to 6 months actually to come up with a small prototype like this. And obviously, that's just the baby steps which we took.
And with zOS workflows come in, do you see more automation available?
Yeah, we are actually closely working with the vendors to see if we have any customized solution, but then we just need to see where we can actually get to. But at this point of time, we're just trying to work out on the solutions both with the vendor and in-house as well.
Okay, thank you. I'm not seeing any more questions come in. So I think that might be it. So thank you so much. That was really interesting.
Thank you.
Thank you. So that was
Thanks a
session
lot, Sophie. Yeah.
4BG, and the QR code's there if everyone can go and fill out their feedback, please. And yeah, with that, I think we're done. So thank you very much.
Thank you, everyone.
Thanks a lot.
Bye.
Thanks
Bye-bye.
everyone for the opportunity, and thanks for taking time. And please do give us a feedback on how we did. And in case you want to see an improvement, please, it would be really helpful.
Thank you.